Hi and welcome to part 2 of the gameplay walkthrough tutorial series that I'm doing with Mxm. As I said before, this tutorial series is predominantly unscripted and it's going to contain things that aren't just about Mxm, some general gameplay stuff to help you guys out with making your characters with Mxm. So this is where we got last time. We've got, our walk and our run, and we've got that calibrated pretty decently and it's working pretty well. This time we're going to add sprint and we're going to improve this a little bit with the locomotion speed ramp. Now, I am aware that yes, we are still doing a fair bit of groundwork even in episode 3, but I want to really stress how much work actually goes into a character in video games. It is a lot. Your character is your main thing. It's in front of your screen all the time. If you're not spending a ridiculous amount of time on your character, especially if you're using motion matching, you're doing it wrong. I don't know how else to say this. Nothing is going to be quick. Nothing is going to be easy. So let's just go on and do this. We're going to add the locomotion speed ramp to further improve the difference between walking and running, and also so that we can add sprint. And we're going to do a bit more setup with the logic graph with bolts. So let's get right into that. Okay, so let's go to our character, and I'm going to go to the behaviors on our character. And remember, we made this player logic script, and that was so that we can have, it's basically like a script library that the visual scripting can call functions from, because I don't want to call every single function and change everything in this graph, because it's going to get too messy with too many wires and probably a little bit too slow. So that's why we have this. I'm going to we're actually going to come back to that and add some stuff soon, but first we're going to add on the locomotion speed ramp. So on our model, alongside the Mxm animator, let's add the locomotion speed ramp. I've already got it there. So here we have the locomotion speed ramp. Our current speed starting at 0. So current speed is 0, which is idle, then walking, running, sprinting. You can and should have a look at the script and customize it for your game, because this is obviously made for a game where you walk, run, and then you sprint on a toggle. So we've got our tags set here. So what this script is going to recognize as the run and the sprint tag, and this is the favor multiplier when those tags are active. And we've also got to set the player transform, which is that. And yeah, so the speed downgrade time is basically, so the way the locomotion speed ramp works is that you can instantly upgrade your speed, so say from a walk to a run, but when you downgrade your speed, there's got to be a bit of a delay so that you can play out the slowdown. So that's like a 0.3, and also so that if you put the gamepad stick through the middle to go to the other side, it doesn't suddenly switch to walking and then you get a walking transition. So that's kind of important. But yeah, have a look at that script and definitely, I'd say, customize it to your needs. But yeah, so these tag names correspond with the tag names in our favor tags in our naming module. If you want to use require tags to differentiate, then you are going to need to go into the script and change them to require tags instead of favor tags. That's not too difficult, but we're going to leave them as favor tags for now. So now that that is set up, I'm actually going to disable it to start with. I'm going to go to callbacks on the Mxm animator, because I only want it to be enabled when the Mxm animator is set up. And to be honest, I'm going to do this for a bunch of things. So if we go to this on setup complete callback, and I'm going to drag the script in here, and I'm going to drop down locomotion speed ramp enabled and true. So now it's only going to enable after Mxm is already set up. I'm going to add another one of these, and I'm going to go to the behavior, and I'm going to deactivate my state machine, and I'll grab my behavior object here. I'll go to the state machine, go enabled, true. So now those things are both going to be enabled after Mxm is already set up. Just in case your update order happens to be different, this will ensure that it only gets turned on after the Mxm is set up, so it's not going to accidentally change anything. So that's a cool little function there. You can use these as you see fit, based on what they are. We will come back to it for, say, left and right foot callbacks and stuff like that. Okay, so that's set up. We've got the locomotion speed ramp. We do need to actually update it. Now, the reason why it doesn't update on its own is because you might not want to have the locomotion speed ramp updating in every possible state. You only want it updating in some states. So in my implementation here, I've left it up to the user to update it in the state machine, for the logic state machine. So let's go onto that logic state machine, and I'm going to hit edit graph. And we have this start state. Now I'm going to leave that as a kind of initialization state. I'm actually going to rename it initialization. And then I'm going to create a new super state. And you know what, I'll make two just so that we know where we're going with this in the long run. So I'm just going to call this unarmed locomotion, or maybe we'll just call it locomotion. Unarmed can be implied, and then we can call this combat. And we're not going to do combat in this episode. I'm just setting it up so that we're getting the general structure here. So make transition and make transition. These transitions are not going to trigger because I haven't set up any trigger events here, but it's just placeholder for now. Now initialization, we want to make transition into locomotion. And then we're going to have a start state in locomotion. So again, we're going to have an initialize. I'm just going to call it init. And then we're going to have general, and then we're going to have sprint. Now, I like to have these init states. Whenever I have a super state, right, I like to have an initialize state so that when we come back from combat, the initialized state can set up everything that is general for the entire locomotion super state. And that means I don't have to duplicate a whole bunch of logic in either one of the states that I have in here, because it's going to go from one to the next as is required. So let's just make some transitions. And what do I call this? I'll call this general locomotion, and then I'm going to call this one sprint. And we can make transition. Now I need to do this toggle start. So I don't want it to start. The green means that it's going to be when we go into this super state, this locomotion super state, the green means it's going to be the first state active. I don't want both of them to be active. I want to init and then go straight to general. And in the init, I am going to call a function. Actually, I'm going to call this function in the overall initialize. And it's going to be, oh, you didn't see that. It's going to be a function we're going to add to our logic. So this is our sort of our logic library. And I've already done the code here. We're going to need bolt. We're going to need Mxm. And then we're going to need a bunch of things. We need access to the variables on bolt. So if you remember here, we have this variables script. And we set up three things: Mxm animator, trajectory generator, and I added another one for locomotion speed ramp. Now, yeah, I could go and drag those in from in the inspector, but what if you're making a character that is made at runtime? Then you're not going to be able to do that. So it's better to set them up through script, and this is how we do it. So we get those variable direct declarations. Well, we need these variables to be stored. Okay, so we've got the Mxm animator, the trajectory generator, and the locomotion speed ramp, and we've got a reference to those variables. When we call initialize behaviors, we first need to get the variables, and that's done by variables.object and then the game object. It's kind of a weird way, but that's how Bolt does it. So it's on this game object that the script is on, so it's going to find those just fine. We need to get the Mxm animator, and the way I'm doing this is I'm going to the transform parent and then get component and children, because remember the Mxm animator is on a different game object, not a child, so we need to go up and then we can get all in children. I'm fine with that in this case. And then we got the trajectory generator. Again, you could actually set these up as, public or serialized fields and then drag them in if you want. I don't like that way because, you miss a reference and then it doesn't work. So trajectory generator, get component, and the speed ramp, we're going to get that component as well. Then we need to set the variables on Bolt. So it's simple. We get this variable declarations and we pass in the name that we gave it. So that's the name that we give it here under variables. And same for all the others. So now all those variables are set. And that is why it's good to have this initialization state, because we get to essentially initialize it once, and this state is actually never going to be revisited ever again, which is good. So let me go back, and I'm actually going to close that and go Tools, Bolt, and we need to update our unit options because we changed our script there. Did I save it? No, I didn't. That's my mistake. Now I need to do it again, I believe. Let's just do it again for good measure. Update unit options. Okay, so that should be accessible now. I'm going to go back to the graph, and we'll go in here, and I'm going to call, so what is it? Player logic is my script name. Player logic dot initialize behaviors. There we go. So we're calling it now because the this flow graph, this state machine from Bolt is on the same game object as the player logic. I don't need to pass in the object for it. I can just call it on self, and that will do just fine. So that's now going to call that function. I'm kind of sick of this bug with Bolt where it wants to keep this up and then, okay, there we go. I've got to delete that now. All right, so that is that. And then what we're going to do is we're going to trigger the transition. So to just manually trigger a transition, we go here and we go custom event. I believe it's called custom event, and init complete, init done. I'm going to call it init done, and then we go there. Now we just need to trigger init done, so I'm going to copy that, and we can go back here, and straight away after we initialize behaviors, I'm going to say trigger, I believe, event trigger. Hang on. What have I done? And I'll just right click and we'll go events and trigger custom event. There we go. And we'll pass that on, and then I'll put that in. So now that's going to initialize behaviors, and then it's immediately going to trigger this event, which is going to go into our locomotion state. Then it's going to init our locomotion. And that's useful because now we can set the a whole bunch of stats on our Mxm animator every time we enter locomotion. Now, I'm going to not do that right now because we've already set up some general stats here, but we are going to want some additional stuff later. So let's now update this locomotion speed ramp. That's the first thing we need to do in here. So let's get our locomotion speed ramp. So go locomotion speed ramp update speed ramp. So we're going to update it in here. We're actually not going to update it in the sprint state because we're toggling the sprint state. Anyway, so that is updated there. And that's all we need to do. We do actually need to pass in the variable. So we're going to go get variable, add unit, get variable. And it is an object variable because it's on our object. I'll plug that in there, and I'm going to click down, and we can see our locomotion speed ramp is there because we had already set it up. So that's now going to call that on the correct function. And so that should be playing now. That should be doing its job. Let's hit play and see if that all works. Okay, so you can see that after Mxm initialized, the callback functions worked, and it is now enabled locomotion speed ramp. And is our state machine enabled? Yes, it is. And you can see that our player logic script has automatically, without calling of our init function, it has actually set these variables here. So that all seems to be working fine. Let's click edit on the graph, and you can see we've gone from here. We've triggered our event successfully. We've gone into the locomotion state, and we're still stuck in the init state. Okay, so we forgot to do one thing. We forgot to set up this transition here. Let's quickly just stop this, and I'll go back here, and let's set up this transition. And I'm going to go and say event, custom event, and I'm going to call it init done. Now, I'm not completely sure, but I believe since it's in a different state, the previous call to init done isn't going to trigger this one. So let's give it a try and see what happens. So init done. I'm going to keep this blank for now. For now, it's just placeholder. So init done. Oh, sorry, I need something else. I need events, trigger custom event, and we'll put init done in there. So that should now go over to our general state where we're going to update locomotion. Yeah, that looks pretty good to me. Usually I use 2 screens for this, so it's easier. I have my graph on another screen, but because I'm recording a video, I have to keep closing it and stuff. I should probably, let's see if I can dock it here maybe. There we go, that should be better. All right, so let's hit play. And I'm just gonna go to my state graph. So we're in locomotion and we are in general now, and this is being updated and we can see all the juice flowing. Awesome. Okay, so it seems to be working, but remember it was already working pretty well. So let's have a quick look at the Mxm Debugger. Now, a lot of people don't know about this, and it's probably just because of not reading the manual, which I get it. It's a big manual, but it's a big asset. So, you know, but anyway, if we go to if we click on our character with this menu open, we get this here. And if we don't have this menu open, we can open it by going to Mxm Animator component, going to debug and open debug window, and that'll open it for you somewhere. Now, nothing's going to happen until we hit record, and you can see when we record, a whole bunch of stuff happens. We can see what the values that the cost function is spitting out. And we can even see the animation channel states here that are flashing like crazy. Now, it may not be super useful to you in this state. However, what we can do is we can hit preview and we can actually go back and forward and see at any individual point. Now, it's a bit difficult to read because of this new update to the dark mode. I'll have to change that soon, but you get the idea. Now, this isn't all you have access to. If you hit this drop down, you've actually got a ton of different options here to view. There's pretty much no data that Mxm uses that you cannot view in this debugger. So I'm going to go to current pose and I'm going to see what tags are active here. So you can see here under input data desired, we got required tags, favor multiply. There's a whole ton of information. As I said, pretty much everything here is recorded and passed to this debugger, and you can rewind and fast forward. And that's a really cool feature. If you add the gizmos on, it actually, shows you the gizmos for the recorded section. You can see up here. So this is an extremely useful tool. If you don't know what's going on, use this and you will know what's going on. It makes a big difference, especially with tags. So now I can actually see what tags are active. And now, unfortunately, it doesn't show the tag names, and I did try to make it show the tag names as we wrote them. It just shows their index. I might try again at some point to do that, but I remember there was some complication which made it difficult. Either way, we can see that something's going on. So when we're slowing down to walk here, it's the none tag, which is correct because we said walking is no tag. And then when we're running around, we have tag 2. So I do recall tag 2 was indeed run. So yes, tag 2 is run. So that's all working fine. The locomotion speed ramp is now working completely, and that's all set up. Very, very cool. Okay, so I'm going to turn off the debugger because it will slow things down. It's not meant for production, that's for sure. And yeah, so we are pretty much done with the debugger. Let's move on to sprinting now. Okay, on to sprinting. Now, the first thing we need is going to have to be a toggle for sprinting. Now, I am using the old input system. At some point in this tutorial series, we will go and upgrade it to the new input system. It's just, this is quick and easy for now. I don't have to change a whole bunch of things. So let's just add in an option for sprinting. I'm going to call it, I'm just going to use this one because I don't have a fire one yet. I'm going to call it sprint, and it's left control. Let's make it left shift. And I'll probably add it to the joystick, but I'll have to look up the mapping because it's weird. And we're going to change this to the new input manager anyway, so input system anyway, so it's not going to really matter. But for now, this will do. So left shift is now sprint. Okay, so we can go to our behavior, edit the graph, and I'll put it up here. And we go here, and in our transition to our sprint, we want to trigger that with an input. So input, let me actually go through here. Is it events input on button input because it's a button that we named, and we can call that sprint. And it's when we press it down, it's going to trigger that transition. And we can do the same thing. I'm going to copy this one here, and in the transition back, when we the sprint is lifted up, we'll transition back. Okay, so those transitions are now set up. Let's go into here. Now on enter state, when we sprint, we actually need to tell the locomotion speed ramp, hey, stop doing your own thing. I want you to just start the sprint. Because that's just how I've coded this thing. So let's go locomotion speed ramp. We'll add a unit, locomotion speed ramp dot begin sprint, simples. Okay, and when we exit, we go locomotion speed ramp, and I think it's reset from sprint. There we go. So when we go in, we begin sprint. When we go out, we reset from sprint. We don't need to update the locomotion speed ramp now. And this is again why I didn't want that as an automatic update on that script. Now that is going to change the tag and do all the good stuff that the locomotion speed ramp does, but there's more things that we need to change specifically on the trajectory generator. We might want to change our calibration, all that stuff. Now, I could go and call individual functions to change every single one of these individually. I think that's going to get a bit too cumbersome. So I am going to make a script for that. But there is one thing that I'm going to do first, and that is I'm going to call something on the Mxm animator. And what is it going to be? It is going to be calibration. Set calibration. Set calibration data, and I'm going to pass in the name. Now, of course, I'm calling stuff from an external thing, so we do need to add a unit to get a variable, get the object variable. In this case here, I'm going to move this out of the way because we're actually not going to have much in update there. And the variable I need is locomotion speed ramp, so we'll plug that into that one. We can plug it into this one also. You could just duplicate it. It's probably going to be less messy if you just duplicate it. Let's just duplicate it. What is it? Right click on them to get rid of them. Just so we can keep these nice and separate. Okay. And we're going to need the same thing over here because we're calling something from an external object, the Mxm animator. So change that to Mxm animator. We're going to change the calibration. Oh no, sorry, that's the calibration name. So we'll get rid of that one. We want the object to be the Mxm animator, and the calibration name is sprint. Because we did make a sprint calibration, I believe. Let me have a quick look. Where is it? Here we go. And animation, calibration override. Yeah, we do have a sprint one. So we're going to change its calibration. And then we're going to have to change a whole bunch of things on the trajectory generator, the speed, the position bias, all that good stuff. Let's do something else. Let's make a function in our sort of player logic library to handle this. So let's call it, so it's void. It's just going to be a bunch of setters. So set trajectory data. And we're going to pass in a bunch of things all at once. So float a max speed, float a der bias, float a, actually this will be der bias. And the reason I'm doing this is because we're probably going to be changing these things a lot altogether. Move bias. And we'll probably want to also change the input profile. So Mxm input profile, so a input profile. Okay, there is that. And from here we can simply go m trajectory generator dot max speed equals a max speed a move bias equals, sorry, m trajectory generator dot that's actually position bias equals a move bias. Again, direction bias equals a der bias. And finally, input profile equals a input profile. So we can change all of these things all at once with just one node instead of a whole bunch, and it just keeps things a bit cleaner. So I'm going to have to update unit options, and we are going to then call player logic and set trajectory data. And we can see we get all these options here. So I'm going to say the speed is 10. I'm going to make the move bias, we'll keep it 1 for now because I'm not sure, but we're probably going to need to change it. And the input profile, I don't know if I have an input profile for sprinting just yet. We'll need to make one. So we've got input profile locomotion. Let's make a folder for input profiles. Remember, we need to keep everything nice and clean. Input profile locomotion, and I'll duplicate that one. We'll call this input profile sprint. Now with sprint, you've either got nothing or everything. So I'm going to delete. Where's my delete button gone? Okay, yeah, this is the same thing as the timeline as I saw before. They've removed the icon that I was using from the editor, so it's invisible. It's over here. I'll fix that in the next update. So we're only going to have 2, which is our stop and our full sprint. So we'll smash that one all the way up to 1.1. From 0.1 to max input, and we'll say this is the magnitude of that and that and that, and 0 magnitude. That's fine for now. We'll tweak this. You can tweak this as you want later. Maybe you want it to be less responsive, in which case you could set this. Actually, we might set this as something like 0.7, so it's a bit less responsive in the sprint. So there we go. That's just one big fat function to call instead of 4 of these nodes. We're all having to have this trajectory generator, like one of these plugged in. It's just cleaner and faster. So yeah, so that's going to be 10. But now that we've done that, we're going to need to do the same thing when going back. So when we go back to our general, we're going to have to do a bunch of things. Now we're already resetting from sprint, so we don't need to worry about the tag, because this begin sprint is the thing that's dealing with those favor tags, and this is undoing that. We are going to need to redo these ones. So let's control copy those and go back to our general state, and under on the enter, we're going to set these values. So we have set calibration, and I'm going to change it to, what was the calibration called? It's just general. I'll copy that in there. So we're setting it back to general. I would recommend actually not using a string, by the way, because it's slower. Use an integer. I know it's a bit more fiddly, but I just think it's better. You could add a variable and cache that so that it's easier to manage if you want. I'm not going to go through all that. Now we need to change all these back to what they would have been. So that is the defaults that we have here. So it's 4, 15, and 10. 4, 15, 10, and we need to change it to our input profile here. Now I just saw something funny, and it might be a bolt quirk, but it's still got the old name here. I'm just going to drag it in again. Okay, delete it, drag it in again just to make sure. Okay, for some reason it remembers the old name. That's weird. Other thing I made a mistake, move bias 1. No, I'll probably keep it at 15. Maybe, yeah, 10, because I'm already using this input profile to shape those down. It doesn't really matter. You can do it either way. But there you go. We have it going into sprint and out of sprint. This should now technically work. The only question is, do I have sprint animations in here yet? And are they tagged correctly? So let's go here. We have our sprint animations. And are they tagged correctly? They do have the sprint favor tag. So that looks all good to me. Let's test it out. It should work for us. I'll put this down here so we can have a look at it as it's working. Hit play. And I'll get the gizmos off. So we're running, and if I hit shift, there we go. We can see we've transitioned into sprinting. I feel like the calibration definitely needs a bit of tweaking, but it is working, and you can see our graph down here. It's in the sprint. If I let go of shift, it goes back to general. And this is a really nice way now. We're finally getting into doing some logic, and I know it's very simple, guys, but instead of having some Boolean that says be sprint equals true or whatever, we now can see what we're doing. We've separated stuff in, we've divided and conquered, and we're going to do a lot more dividing and conquering. And we keep all our logic separate. It makes it much more easy to manage, and in this visual way, it's just good. As I said before, I'm not a big fan of visual scripting, but when it comes to state machines, I think it's absolutely vital. Doing state machines through code, I've done that a lot over the last 10 years or whatever, but I don't ever want to do it again. Unless it's a very simple state machine for a very specific use. For example, Mxm has an internal state machine for idle states, events, and general motion matching. But that's never going to be different. Gameplay logic becomes extremely complex, and that's why we really want this here. And we set up this simple thing. Now we're never going to get confused with our sprint and our general. Let's see what happens if I press shift. You can see we get the nice deceleration from sprinting to running. It's not just an instant thing because we're using favor tags, and we have those decelerations. Same with the accelerations. What happens if I let go of the keys? We get this long sprint stop. Perfect. That's working really well. And I believe I said something about it in the last episode with the calibration module. By setting this body velocity weight to double, we're maintaining our momentum a bit more. I'll just show you what happens when I put it to like 2. I don't think we're going to get that quick stop. And we do still get it. And the reason why is also because our trajectory generator, we've slowed that down by using this input profile. We've put it to 0.7. If it was faster, if that trajectory comes back faster, we might cut our stop short. But anyway, I like it like that. I'm in this hypothetical game that we're making here. I want sprinting to be unresponsive. I feel like it's meant to be unresponsive. You've got to have a trade-off for running super fast, and it's either some obscure what is it? Some obscure sorry, I'm mind blanking. Stamina system, or you're just less responsive. It's harder to move around. We can make it a little bit more responsive. I feel it might be a bit too much. So let's put this up to 0.7. Actually, we'll leave it at 0.7. Because the trajectory is going to be so long, we might. We'll just leave that. Let's leave all of that there. The neck position, we could weight that a bit higher, just like we have up here, just for a bit more stability. But I think it was already pretty good from the start. Maybe a bit too slow on that stop now. A bit of a delay. So let's maybe put this down to 5. It's getting there. It's close enough for now. And this is another important thing that I feel like a lot of people need to learn, is that when you get close enough, if you've got lots of big features in your game that aren't finished, just stop at close enough, come back to it later. Obviously, don't do things dodgy and then have a nightmare later to fix, but this isn't dodgy, this is a decent setup. It just requires some tweaking later on, and I'm fine with leaving it as it is for now. So that is sprint and locomotion speed ramp. It took a while to get there because there was a lot of new stuff we're doing here with the graph. So I might leave this tutorial there, and we'll see you in the next one where we will do something else. There's been requests for combat attacks. We're going to definitely go through those, and I might have something special to give you guys just specifically for that. We're going to set up a character slot system so we can have like attachments. Unity doesn't have a slot system like Unreal does, which is annoying, so you have to make your own. And trust me, it's really good to have that there, and that actually will sit on our model. Anyway, we'll get into that in the next episode. So yeah, thank you for watching. See you in the next one. Hope this helps.